Hey guys, in this video I'm going to run through all the solutions for the Edexcel AS Paper 1 for 2024. Every question is timestamped so you can easily skip to a question or rewatch it if you want to. Hope you find this helpful. Okay, so here we are at the front of the paper, going straight to question 1. It says, can we integrate 2 root x minus 3 over x squared? So first thing we're going to do is simplify the fraction down just to powers of x so we can apply our rule. So splitting up the fraction, start off with, that would be the integral of 2 root x over x squared minus 3 over x squared. And then root x is just x to the half. A half minus 2, using the division rule for the powers, is going to be minus 3 over 2. So the first term is going to be the integral of 2x to the minus 3 over 2. And then 1 over x squared, just x to the minus 2. That's just minus 3 lots of x to the minus 2. Then integrating, we're going to raise the power by 1. So minus 3 over 2 plus 1, that's minus a half. If we divide by minus a half, that turns the first term into minus 4x to the minus half. And then raising x to the minus 2 by 1, that's minus 1. Minus 3 divided by minus 1 would be plus 3. We have plus 3x to the minus 1, and then we need to write a plus c. Okay, so now moving on to question 2. We've got a function f of x, which is 2x cubed minus 3ax squared plus bx plus 8a. A and b are constants. Given that x minus 4 is a factor of f of x, show that 10a equals 32 plus b. Well, if x minus 4 is a factor, then we know that f of 4 must equal 0. So plug in 4, it should come out as 0. Let's do that. So that would give us 2 lots of 4 cubed minus 3a times 4 squared plus 4b plus 8a, and again that should come out as 0. If we simplify now, so 4 cubed, that is 64, times that by 2, that would be 128. Then we got 4 squared, 16, times that by 3, that would be 16, 32, 48, so minus 48a. Then plus the 4b plus the 8a. Cancelling down a bit further now, we can actually divide everything by a factor of 4. So let's do that. So 128 divided by 4. That's 32. We have 32. Then it'd be minus 12a plus b plus 2a. Then if we bring the a's together, that would be 32 minus 10a plus b equals 0. And if we rearrange that, we were at the answer they asked for. So that's 10a equals 32 plus b. Cool. Moving on then, it now says that x minus 2 is a factor of f of x. And then can we express it in this form here, where we need to find this constant k? Well, first off, let's think, well, we've got some more information. Similar to the last bit, we know x minus 2 is a factor of x, so let's apply that first. So that means f of 2 must be equal to 0 now. So that would be 2 lots of 2 cubed, then minus 3a times 2 squared, plus 2b, and the last bit is plus 8a. Simplifying that down again. So 2 cubed is 8, times that by 2. Sorry, this should be equal to 0. 2 cubed is 8 times by 2. That is 16. Then 2 squared is 4, times that by 3. That's going to be minus 12a plus 2b plus 8a equals 0. Let's simplify that down a bit. So we'd have 16 plus 2b minus 4a equals 0. Let's divide everything by 2. So we'd have 8 plus b minus 2a equals 0. Let's rearrange this for b, actually. So if b would then be 2a minus 8, and we'll just note we had another equation from part A that was an equation in terms of a and b. So we had 10a equals 32 plus b. So if we have two variables and two equations, we know we can solve simultaneously to get a and b, which will definitely be helpful. So let's substitute this b into here. So that would be 10a equals 32 plus 2a minus 8. Solving now for a, or simplifying up, so we'd have 8a on the left, 32 minus 8, that would be 24, which is going to give us a equals 3, which means that b would equal 2 lots of 3, that's 6, minus 8, that's minus 2. So we have a and b. Let's think about how that helps us now. So our equation now for f of x is going to be 2x cubed minus 3ax squared. So 2x cubed minus 3a, which would be 9x squared. And then plus bx, so that's another minus 2x. And then the last bit is 8a, so 8 times 3, that's 24. So plus 24. And they said write it in this form. So 2x plus k times x minus 4 times x minus 2. So 2x plus k times x minus 4, x minus 2. So what's the easiest way to work out k? Well, I'd say if we think about the final number here, we know that these three numbers must multiply to give us that. So we know that then k times minus 4 times minus 2 must give us 24. Or in other words, 8k must equal 24, which would just give us k equals 3. That's that part. So then it says for part C, state the number of real solutions. Well, we've got 3 factors. So the 3 solutions, there would be 3 solutions total. And then for the last part of part C, write down the largest root of equation f of a third x. Well, first off, what are the roots of these guys? So we found k to be 3. So that gives us this guy's root would be x is minus 3 over 2. This one would be x equals 4. And this one would be x equals 2. So that's the roots of the regular f of x. But f of a third of x is a graph transformation where we're going to multiply all the x coordinates by 3. So it's still going to be this being the largest root, but we're going to multiply it by 3. So that would be x equals 12 for part 2. Moving on to question 3. It says, relative to a fixed origin O, point P has position vector 9i minus 8j and Q 3i minus 5j. Can we find the vector of PQ? So that's just simply subtracting the position vectors. So PQ would be OQ minus OP. So that's going to be 3i minus 5j, take away 9i minus 8j. So 3 minus 9, that's minus 6i. And then minus 5, double minus 8, that's going to be plus 3j. Right, then next bit says, given that R is the point such that QR equals 9i plus 18j, show that PQR is 90 degrees. So personally, I would prefer to visualize this now to understand the problem a bit better. So let's draw some axes. That's the x and y axis here, let's say. And then first off, we've got point P. That's 9i minus 8j. Let's say that's about here. 9i minus 8j. That's point P. Then point Q is 3i minus 5j. Let's say that lives about here. A bit lower. 3i minus 5j. And it says Q to R, so that's a vector going from Q to this new point, is 9i plus 18j. So it's going to go along 9 and up 18. So let's say it looks a bit like this. That this vector here is 9i plus 18j. And that's point R here. And it's asking us to show that this is a right angle. So let's just use what we know about straight lines. If we calculate the gradient of the line going from Q to R, well, we can see we go up by 18 if we travel along this vector QR, and we're going along 9. So that would give us a gradient of 2. Then the gradient of Q to P, where we're going down by 3, and we're going along 6. That would give us a gradient of minus a half. And we can see the gradients do multiply together. Sorry, that was the gradient of QP here, not QR. QR times the gradient of QP. They do multiply together to give minus 1. i.e. they're negative reciprocals of each other. So therefore, they must be perpendicular. Right, then the last bit says, given also that S is the point such that PS is 3QR. So that's the same vector QR, but we're going to start from P, and it's going to be 3 times as long. So my scale is not going to be great. But to make my diagram look a little bit nicer, I'm not going to worry about that. But let's say that's P to S. So that's the point S here. And these guys are then parallel, which makes this... Sorry, that's just the point S. Not point S. Yeah, these two guys are parallel, and that means the PQRS must be a trapezium. So to find the area of a trapezium, we can do half the sum of the parallel sides times the distance between them. So parallel sides, that would be QR and PS. So that's going to be a half of the magnitude of QR plus PS. And the distance between them is going to be this side here, so from Q to P. So times the magnitude of Q to P. Then we just need to find these magnitudes. So the magnitude of QR is going to be, well, we were given QR is 9i plus 18j. So it's the square root of 9 squared plus 18 squared. We type that in the calculator. That's 9 root 5. Then P to S. So P to S was... sorry, where's P to S? Oh yeah, 3 lots of Q to R. Okay, so then that's easy. It's just 3 lots of that. Yep. P to S. So that's 27 root 5. And then the magnitude of Q to P. Q to P was 9i plus 18, sorry, minus 6i plus 3j, but in reverse. But that's not going to affect the length. So it's going to be the square root of 6 squared plus 3 squared. So typing that in the calculator, square root of 6 squared plus 3 squared. That's 3 root 5. And then plugging it all into our formula to get the area. So the area then would be a half of 9 root 5 plus 27 root 5 times 3 root 5. That's going to be, typing it all in, a half times 36 root 5 times 3 root 5, which gives us 270. Moving on now to question 4, we've got a triangle with some information. It looks like most of it's already labeled on, but what I like to do is just label on anything that's easy to find. So we can add on some extra angles here. We know that's 150, if that might be useful. And then, just because the total internal angle of a triangle is 180, we know that must be 10 degrees. Okay, so then it's asking for us to find x to 3 significant figures. Well, it looks like we've got most of our information with this triangle DCB over here, so let's use that. We know all 3 angles, and we haven't got side angle side really, and we don't know all 3 sides, so I would say let's use the sine rule then. So if I use, let's say we use side DB with angle C, well, the angle here, and then this side with this angle. So the sine rule would then say, for part A, that we'd have x over sine 30 equals x plus 3 over sine 140. Then let's multiply up to get rid of the fraction. So multiplying both sides by sine 30 and then sine 140, we'd have x times sine 140 equals x times sine 30 plus 3 times sine 30. Then if we bring the x's together and then we factorize, or let's just do it in 2 steps actually. So x sine 140 minus x sine 30 would equal 3 sine 30. Then we can factorize, so x open bracket sine of 140. Oops, oh no, I was right, yeah, minus sine 30 equals 3 sine 30. And then we can divide. We'd have 3 sine 30 all over sine 140 minus sine 30. Putting that in our calculator just to check it actually does come out correct. Where's the clear button? There it is. So fraction, we'd have 3. Oh, I'm in radians, let's fix that. Settings, calc settings, angle unit, degrees. Cool. Right, so fraction 3 sine 30 over sine 140 and then minus the sine 30. So that does indeed give us 10.5 to 3 significant figures. Okay, then for part B, it says given also that the length of AD is x minus 2, so that's on the diagram already. Find the length of AB. Well, now that we have x in this triangle here, so ADB, we do have side, angle, side. So that is the angle specifically between 2 sides, so that means we can use the cosine rule. So cosine rule, if we write that out, this is how I write the cosine rule out. I say it's c squared equals a squared plus b squared minus 2ab cos c. You might have the letters rotated around potentially if the way you write it out, but it's all the same. Good. So we're after the length AB, so that's our c, right? So AB squared is a squared b squared. So let's actually write out what AD are and DB are. So that was 10.5. 10.5 minus 2, that would be 8.5. And plus the 3, that would be 13.5. So then we're going to do 8.5 squared plus 13.5 squared. And then minus 2 times 8.5 times 13.5. And then times cosine of our angle, which was 150 degrees. So typing that out in the calculator, we're going to get 8.5 squared plus 13.5 squared minus 2 times 8.5, 8.5 times 13.5 cosine of 150 degrees. That's 453. .2 something, and then we're going to have to square root that. So let's take the square root of our answer. There's the answer button. Is 21.3 to 3 significant figures. What's significant figures? Yeah, 3 significant figures. Good. Moving on to question 5. It says the curve C1 has equation y equals 6 over x plus 3. Sketch C1 stating the coordinates of any points where the curve cuts the axes, the coordinate axes, and then part 2, state the equations of any asymptotes to the curve. Well, for me, I like to think of that as, well, it's a 1 over x graph that's being transformed somewhat. So if we start with f of x equals 1 over x, to get this equation for y, it would be, to get 6 over x, we just have to multiply the function by 6, so that would be 6 lots of f of x. And then we need to add 3. So as graph transformations, we've stretched all the y coordinates by 6, and then shifted it up by 3. So the stretch in the y by 6 isn't really going to do much to our graph, but shifting it all up by 3 is certainly going to change it. So let's sketch that now. So here's some axes. Here's my x and y axes. So let's think about the asymptotes first. So normally the asymptotes are just along the axes, but the horizontal one, that's normally where y equals 0, that's shifted up by 3. Well, first multiplied by 6, but that doesn't do anything, and then added up, shifted up by 3. So that would be up here then. So that would be at y equals 3. We still have the usual one, the vertical asymptote, but that our transformations don't do anything to that one. That's still x equals 0. And then we've got, to actually put the graph in. So the graph still looks like what it's normally going to do. It's going to cut in on these asymptotes, and then it's going to cut in like this. So we've stated the equation of the asymptotes. We need to find where the curve cuts the coordinate axis. So it only cuts the x-axis at this position here. So to find that, that's going to be setting the whole equation to 0, the y-coordinate to 0, excuse me. So we have 6 over x equals, plus 3 equals 0. That's going to be 6 over x equals minus 3, which means x would then be 6 over minus 3, or minus 2. So this point here is minus 2, 0. Good. Moving on, it says the curve C2 has equation y equals 3x squared minus 4x minus 10. Show that C1 and C2 intersect when this is true. Okay, so to find where two lines intersect, we're just solving simultaneous equations. The x and y coordinates must be the same. So we can substitute out the y's would be the easiest thing to do here. So doing that, we had 6 over x plus 3 for the y coordinate of our first one. And that must just be the same as the y coordinate for the second one, which is 3x squared minus 4x minus 10. And straight away, I want to deal with this 1 over x. So let's just multiply both sides of the equation by x. So that turns the first time just to 6. And this would be 3x, then 3x cubed minus 4x squared minus 10x. Right, that's a squared there. Then let's collect all the terms on the right-hand side. So we'd have 3x cubed, then just minus 4x squared. We've got minus 10, but minus another 3x on the left, so that'd be minus 13x. And then take the 6 over the other side, that'd be minus 6 equals 0, which was what they asked for. Then it says, given that the x-coordinate of one of the points of intersection is minus 2 over 3, use algebra to find the x-coordinates of the other points. So they've given us one solution, so we can use that. We know that must be a factor. If it's equal to 0, we have a solution that corresponds to a factor. So the factor that would give us a solution of this would be 3x plus 2. So we can divide this by 3x plus 2 with long division. So let's do that. So 3x plus 2 dividing into 3x cubed minus 4x squared minus 13x minus 6. So 3x cubed divided by 3x is going to give us just x squared. Then multiplying through, that gives us 3x cubed plus 2x squared. Subtracting off, minus 4 minus 2 is minus 6x squared. Then bringing down the next term, that's a minus 13x. Then repeating the same process, so minus 6x squared divided by 3x, that's going to be minus 2x squared. And then multiplying through again, we get minus, we get minus 6x squared. Then we get, sorry, that's not an x squared there. That's just an x up here. Good, but multiplying through, we do get minus 6x squared. And then plus 2 times that, that's minus 4x. Subtracting off one more time. We're just left with minus 13, double minus the 4, that's minus 9x. And then writing down the next term, so minus 6, just bringing that down. Minus 9x divided by 3x, that's going to give us minus 3. Multiplying through just to check it all works. That's not right. 3x times minus 3, that's minus 9x. 2 times minus 3 is minus 6, so we do get remainder 0. So now we know that we could factorize this equation, our original one, is going to be 3x plus 2 times x squared minus 2x minus 3, and that's equal to 0. And then we've got a quadratic that we can pretty easily factorize. So it's going to be x minus 3 and x plus 1. So our solutions, we have the one we were given, minus 2 over 3. We have 3, and we have minus 1. Moving on to question 6. It says the binomial expansion of 1 plus ax to the 12 up to the x squared term is 1 minus 15 over 2x plus kx squared, where a and k are constants. Can we show that a is minus 5 over 8? Well, to use that information, we're going to need to do our own expansion. So let's do that first. So 1 plus ax to the 12, that's going to be 1 to the 12 plus 12 choose 1 times 1 to the 11 times ax. then it's going to be 12, choose 2, times 1 to the 10, times, 1 to the 10, not that it's going to matter. 1 to the 10 times ax all squared. So that's 1. 12 choose 1 is 12, so just 12 ax. And then 12 choose 2. Let's get that from the calculator. So 12, then go to probability, combination, 12 choose 2. That's 66. And it's ax all squared, so that's a squared x squared, so it's going to be plus 66 a squared x squared. So then we're going to have, if we want to find a, we can compare the coefficients. So we have 12a for x here, and they have minus 15 over 2. So 12a must equal minus 15 over 2. If we simplify that, that means a is going to have to be minus 15 over 12 times 2. We can divide the top and bottom by 3 in that. So that would leave us with minus 5 over 8. Then it says, can we find the value of k? Well, k is the coefficient on the x squared term, so we can do the same trick where we just compare our coefficient of x squared with theirs. So k must equal 66a squared, but we know a is now minus 5 over 8. So it'd be 66 times minus 5 over 8 all squared. Let's use the calculator for that. So 66, open bracket, minus 5 over 8, over 8, close bracket, all squared. That gives us 825 over 32. Part C then says, can we get an estimate for 17 over 16 to the 12 to 4 decimal places? Well, our expansion was for a power 12, so we just want the inside, the 1 plus ax, or our a was minus 5 over 8, so we want 1 minus 5 over 8 x to equal 17 over 16. So then we'd have 5 over 8x would equal minus 1 over 16. And then timesing by 8, that would be minus a half, divided by 5, that would be minus a tenth. So we want x to equal minus a tenth. So to get our approximation, we need to sub that into either theirs or our approximation expansion. I'm going to use this one just to make it easier. They're the same thing. So we're going to have, when x is minus 1 over 10, 17 over 16 to the 12 is approximately 1 plus minus 15 over 2 times x, so minus 15 over 2 times minus 1 over 10. And then it was plus the k, which was 825 over 32. So plus 825 over 32 times, don't do what I'm doing here, but just write it down here, minus 1 over 10 squared. If you plug that in the calculator, it'd be 1 minus 15 over 2 times minus 1 over 10 all squared. Sorry, not squared, that one's just as it is. Then we're doing plus 825 over 32 times minus 1 over 10 all squared. And that we want it as a decimal, so let's turn it into a decimal. That's 2.0078 to 4 decimal places. Okay, moving on to question 7. We've got some logarithmic axes plotted, and it says a chimney emits smoke particles. On a particular day, the concentration of smoke particles in the air emitted by the chimney is P parts per million, and it's measured at various distances x kilometers from the chimney. And it mentions the figure with a straight line plot. And then we pass through these 2 points, 0, 3.3, and 6, 2.1. And it says complete the equation for the model in this form. So this is one of these standard models where we can turn it into a log plot. So let's do that by actually logging the equation. So if we have log base 10 of p on the right, then we have log base 10 of ab to the x on the right. And then we can expand the logs on the right. So we'd have log base 10 of p. Using the multiplication law, we could write that as log base 10 of b to the x plus log base 10 of a. And then we can use the power law for logarithms. We can bring that x down from the power and just have it multiplying outside. We have log base 10 of p equals log base 10 of b times x plus log base 10 of a. And now if we compare this to a y equals mx plus c relationship, well, we can see our axes, our y-axis is the log base 10 of p, and the x-axis is just x. So that must mean the gradient, m, is going to be log base 10 of b, which we can calculate from the points of the graph. So that means log base 10, log base 10 of b going to be the gradient, which is where we go down by 1.2, so minus 1.2 over, we go along 6. So b is going to be 10 to the power of minus 1.2 over 6. It wants that to 4 significant figures, so let's put that in the calculator. 10 to the power of minus 1.2 over 6. That gives us 0.63, and it's going to round up actually to 0.6310. And then log base 10 of a is going to be r plus c. So log base 10 of a is our y-intercept, which is just 3.3. That makes a 10 to the power of 3.3. Plugging that in, 10 to the power of 3.3 is to 4 significant figures is just going to be 1,995. Okay, then it says, with reference to the model, interpret the value of AB. Well, A in this form is like the initial value. So that's that would be the parts per million of smoke 0 kilometers from the chimney. And then timesing it by B each time is like, normally we think about it in time, it would like be after 1 year, or in this case, it's going to be each kilometer away. So AB to the 1, which is what we have here, that's going to be the amount of smoke in parts per million. So this is what? This is question B. So AB is the smoke in parts per million 1 kilometer from the chimney. Oops. Chimney. Moving on to question 8, it says figure 3 shows a sketch of the curve C with equation x cubed minus 14x plus 23. Given that the tangent has equation y equals minus 2x plus 7, show using calculus the x-coordinate of A for that tangent is 2. So we know the gradient at A must be minus 2 if that's the tangent. So we're going to need to differentiate to confirm that that is the x-coordinate. So if we go to the equation, which is y equals x cubed minus 14x plus 23, plus 23, then we differentiate to get the first derivative. That gives us 3x squared minus 14. And we're interested in the points where the gradient is minus 2. So we'll set this to minus 2. Solving that, we'd get 3x squared equals 12. So x squared would equal 4. And indeed, there's like x equals 2 is a solution of that. There's also another solution of minus 2, but that's not what the question's asking. It's asking for this guy, which is clearly a positive x-coordinate. Good. Moving on, the line L cuts C again at the point B. Verify that the x-coordinate of B is minus 4. Well, B is just where our tangent intersects that. So that just means the y-coordinate, and that point should be the same on both equations. So if we sub in x is minus 4 into both, and it gives the y-coordinate to be the same for both, it must be the point of intersection. So if we first sub into the curve when x is minus 4, the curve C gives us y is minus 4 cubed minus 14 times minus 4 plus 23. Using the calculator to work that out, we'd have minus 4 cubed minus 14 times minus 4 plus 23. That gives us a y-coordinate of 15. And now to verify it, we need to make sure we get the same thing on the line, on the tangent. So y gives us, it was minus 2x plus 7. So minus 2 times minus 4 plus 7. Yeah, which does work, doesn't it? So it's 8 and then plus 7, which is 15. Good. Okay, so that's part B done. Now it says, can we find this shaded region R using integration, which we're definitely going to need because it's a curved area. There's no other way for us to get the precise area. So what I'll always do when I want to find one of these areas, if it looks a little bit strange, I'll draw in some vertical lines on the left and right side of the area. And what we can see now is that produces another shape for us as part of this area. So it produces us a trapezium. So to get R, we can do the integral from B to A of the curve, and then we just need to take away the trapezium. So let's start with that. Setting up our integral, we'd have the integral from B was minus 4 and A was 2, so from minus 4 to 2 of our equation x cubed minus 14x plus 23, integrating with respect to x. So then integrating that, we'd have a quarter of x to the 4 minus 7x squared plus 23x, evaluated between 2 and minus 4. So using the calculator again to work that out, we have a quarter of 2 to the power of 4 minus 7 times 2 squared plus 23, plus 23 times 2. So our upper limit gives us a 22. Now plugging in the bottom limit, that's a minus 4. So let's go replace all these 2's with minus 4. So there, and here. That gives us minus 140. But it's the bottom limit, so it's a double minus. Minus 140. So that's going to be 22 plus 140. Which is 162. And then using our trapezium, so the area for trapezium, we used this earlier, was a half a plus b times h. So that's half the sum of the parallel sides. Well, our parallel sides, we worked out one of them. One was 15. That was the y-coordinate of b. So 15. Then the other y-coordinate is for a. We don't know that at the moment. We could quickly work it out, though, because the x-coordinate is 2. If you plug that in here, it'd be minus 2 times 2. That's minus 4. Plus 7, that's 3. So 15 plus 3. And then it's the distance between those parallel sides, which goes from minus 4 to 2. So that would just be 6. So that's a half times 18 times 6. That's 9 times 6, which is 54. And then finishing off doing if we subtract our integral, subtract that from our integral. So the integral we had was 162 minus 54. That gives us 108, which was what they asked for. Moving on now to question 9. We've got P is log base A of 16 and Q is log base A of 25, where A is a constant. Find in terms of P and or Q, first off, log base A of 256. So we want to really think, how can I express this log in terms of those logs? Or first, really just think, how can I relate 256 to 16 and 25? I think, I'm going to check with the calculator, that actually 16 goes into 256. So 256 divided by 16 is just 16. So it's 16 squared then. So for part A, that's log base A of 16 squared. And then using our log rules, we can bring down that power. So that's 2 lots of log base A of 16, which was just then 2 lots of P. Then for part B, we got log base A of 100. Well, log base A of 100 is just 4 lots of 25 is the easiest way to get something in. We got log base A of 4 times 25, which we can split up as log base A of 4 times, plus log base A of 25. And then log base A of 25 is good because that's Q, but what can we do with log base A of 4? Well, 4 is actually the square root of 16. So we could write that first as log base A of 16 to the power of a half. And then this guy is just Q. And then using the same rule we had before, that's a half of log base A of 16 plus Q, or in other words, it's a half of P plus Q. Okay, so then the last bit's a little bit strange, it's a little bit more difficult, but first off we're going to say, well, 80 is divisible by 16, I'm pretty sure. If we do 80 divided by 16, that's 5. So we can write that as log base A of 16 times 5. And then 3.2, it's a little bit weird, but I think like 32 would be nice. So if you think times it by 10 and divide it by 10, that kind of gets us something closer. So let's say it's log base 10 of 32 over 10. And now we can use our rules again. So if we split this up a bit, sorry, that's meant to be a 16, isn't it? Not a 15. That's 16 there. So that's log base A of 16 plus log base A of 5. This is a bit weird, but times, all in brackets, this other one, which is log base A of 32 minus log base A of 10. And let's copy this to the next page quickly. We got a bit there we didn't want, but we just erased that quickly. Right, well, log base A of 16 was just something nice. That's just P. So that's good. So that's P plus, well, 5, that's the square root of 25. So let's write that as log base A of 5 to the half. Sorry, 25 to the half, excuse me. And then 32 is 16 times 2, so we can split that guy up again. That's log base A of 16 plus log base A of 2 minus log base A of 10. So we can simplify this a bit more now. So that half could come down to leave us with half log base A of 25, which was Q. So that's P plus a half Q in that first bracket. That's good. Then the log base A of 16, that's P again. And then we can combine these two logs I've generated here. So that's 2 minus log base A of 2 minus log, that's 2 over 10, which is a fifth. That's plus log base A of a fifth, which we can maneuver that around a bit. So that's 5 to the minus 1. If we bring that down, that would be P plus a half Q then. P plus, well, let's write it out. In fact, let's just take a minute and take a second line here. So log base A of a fifth is log base A of 5 to the minus 1, which is minus log base A of 5, which again is this same thing we had here. So it's the exact same thing. It's like if that's 5 is 25 to the half, bring the half down, that's just going to make it minus a half log base A of 25, which is then minus a half Q. So then we have our final answer. It'd be P plus a half Q, then P minus a half Q, or it's a difference of 2 squares, so we can expand it out pretty quickly as well. We could write it as P squared minus a quarter Q squared. Moving on to question 10, it says figure 4 shows a sketch of the circle C with 2 points P and Q. So P is the center of the circle and Q is a point on the circle. As the line L is the tangent to C at Q, K is a positive constant. Given that the gradient of L is minus 2, show that K squared minus 3K minus 10 equals 0. So the two key pieces of information there really are as L's a tangent, which means it's perpendicular to the radius. So we could find the gradient of PQ using our points, and then we know the negative reciprocal of that would be minus 2. Or let's think about it, probably the easier way to think about it is the gradient of our radius is the negative reciprocal of minus 2, which is a half, which is the gradient of PQ. So we can use that to generate an equation, because the gradient of PQ would be change in y over the change in x, right? So k squared minus 2k minus all of this, so put it in brackets, k plus 8, all over 3 minus 1. So simplifying, oh, I'm sorry, that should equal a half. So simplifying the top, we get k squared minus 2k minus another k, that's minus 3k, and then minus an 8. And on the bottom, we're going to get 3 minus minus 1, that's 4, which gives us a half. And sorry, there's a half on the other side. And then we just have to multiply up. That would give us that would give us k squared minus 3k minus 8 equals 2. And if we take the 2 from both sides, we're going to get the equation. So k squared minus 3k minus 10 equals 0. Then it says, can we find an equation for c? Well, we're going to need, we've got this equation for k. Let's solve k, because then we have some actual points in p and q. So how are we going to solve this guy? We could use our calculator, or we could complete the square. I think to make things easier, I'm just going to use my calculator. What does it Oh, no, sorry, it factorizes, doesn't it? Yeah. We could do k minus 5 and k plus 2, actually. That's quicker, isn't it? Good. Cool. So then k would equal 5 or minus 2. Now we have a decision to make about what value of k. Let's go back to the question. It says k is a positive constant in the question. So that means k must equal 5. And it's so to find an equation for c, we need the center and the radius. Well, we've got the center now. That's just point P. So P is minus 1, and then it was k plus 8. So that would be minus 1, 13. And then Q is 3 and k squared minus 2k. So that's 5 squared minus 10. 25 minus 10, that's 15. And the x-coordinate was 3. Cool. So this is our center. We're going to get the radius, we'll just do the distance between these 2 points. So our radius would be the square root of minus 1 to 3. That's going along 4. So 4 squared plus 13 going up to 15. That's 2 squared. So that's the square root of 16 plus 4. That's root 20. So the equation of our circle then would be the center, so minus 113, so that would be you get x plus 1, then y minus 13 squared would equal the radius squared, which would be just 20. Moving on to question 11. It says the price of 2 precious metals are given by, metal A is 100 plus 20 e to the 0.04 t, and metal B is p e to the minus 0.02 t, and just take note of the unit. So the value is in pounds, and then t is in months. So just bear that in mind for later. But it says, here's our information now. So VB equals 2VA when t equals 0. So we can make an equation out of that to solve for p. So let's just get the values at t equals 0. So at t equals 0, VA is going to be 100 plus 20 to the 0, so that's just 120. And VB is going to be p times e to the 0, so that's just p. And then it says VB is 2 lots of VA, so that would make B equal to 2 lots of 120, which is 240. Then it says when t equals t, the rate of increase, the rate in the price per gram of metal A was equal to the rate of decrease in the price of metal B. And then can we find that value of t? So if we want to find the rate, that's the derivative, so the rate of change with respect to time. So we'll differentiate both first. So dVA by dt. That's going to be bringing down the 0.04. The 100 goes to nothing. Bringing down the 0.04. Let's put that in the calculator. So 20 times 0.04. That's 4/5. So we have 4/5 e to the 0.04 t. Then for metal B, we have 240. Bring down the 0.02 or the minus 0.02. So 240 times minus 0.02. That gives us minus 24 over 5. E to the minus 0.02t. And it says the rate of increase of this guy is equal to the rate of decrease of this guy. So we can set them equal to each other, but we're just going to forget about the minus sign. This is the fact it's a decrease, basically. So that means we have 4/5 e to the 0.04t equals minus 24 over 5 e to the minus 0.02t. We can cancel off the fifths from both sides. And, sorry, I mean to forget about that minus sign. Don't need that. 24 divided by 4 is 6. So we'd have e to the 0.04t equals 6 e to the minus 0.02t. And if we think about it like minus e to the minus e to the minus 0.02t is just 1 over e to the 0.02t. So if I want to simplify this, I can just multiply that to both sides. And then that's just going to add to the power on the left-hand side. So that'll just make this e to the 0.06t would equal 6. So that's going to make t 1 over 0.06 natural log of 6, which if we type that in the calculator, 1 over 0.06 natural log of 6 gives us 29.86, or to 1 dp 29.9. Oops. Moving on to question 12, it says, figure 5 has the plan view of the design of a swimming pool. It's modeled as a quarter of a circle with 2 rectangles. And we've got the sides of the rectangles, and it says the radius of the circle is x. And we're also given that the area of the swimming pool is 100. And it says show that the perimeter of the circle, the perimeter of the pool is this. So let's start off by actually expressing the perimeter. So the perimeter is going to have 2 lots of that side x. That's here and here. And it's going to have 4 lots of y. So that's there, 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 and there. So let's write that down. The perimeter is 2 lots of x plus 4 lots of y. And then we've got the curved side of the pool, which is a quarter of the circumference of a circle. So the full circumference is 2 pi r, or 2 pi x. Divide that by 4, we'd get a half pi x. So plus a half pi x. Then our equation has a y in it. So we need another equation to get rid of y. That's where this area is going to come in. So the area, to get an equation using that, we've got 2 lots of the rectangle, which is just xy. And then a quarter of a circle, well, the full circle is pi r squared or pi x squared. So a quarter of that, a quarter of pi x squared. So we know the area is 2 lots of xy plus a quarter of pi x squared, which is going to be 100. And now we can use this, we can rearrange for y to be able to substitute out y in our perimeter equation. So let's rearrange for y. Y would then be, well, first off, let's say it's 2xy, let's start off with, would be 100 minus a quarter pi x squared. Then divide everything by 2x. So we'd have y would be 50 over x. And then minus, let's call it pi x over 8. Now we can substitute this guy, into here. So that gives us the perimeter to be 2x plus 4y. Plus the y, which was 4 plus y, which is 50 over x, minus pi x over 8. And then plus this half pi x again, or let's call it pi x over 2. Then simplifying, we have 2x, 4 times 50 over x, that's 200 over x. Then pi x on 8 times by 4, that's going to be pi x on 2. So minus pi x on 2, and then plus the pi x on 2, they cancel out, which is nice and leaves us with the answer we wanted. Part B then says, use calculus to find the value of x for which p has a stationary value. So that's when the derivative is 0. So we need to differentiate this. So first let's write it in powers. So p is 2x plus 200 x to the minus 1. dp by dx then would be 2 minus 200 x to the minus 2. And if we're after a stationary value, that's where the derivative is 0. So rearranging, we'd have 200 x to the minus 2 equals 2. So x to the minus 2, that's 1 over x squared. So let's just multiply up by the x squared. That gives us 2x squared equals 200, or x squared equals 100. And then x would be plus or minus 10, but minus 10 doesn't make much sense, so let's call x equal to 10. Then it says, prove by further calculus that this is this value of x gives a minimum value of p. So we can check that with the second derivative quickly. So if we find d2p by dx squared, differentiating this guy again, bringing that minus, the 2 goes to nothing, the minus 2 coming down is going to make that 400 x to the minus 3. And then we're interested in when x equals 10. So then our second derivative would be 400 over 10 cubed, which I don't really care about the value. All I care about the fact is that it's positive, because that means there's a minimum at x equals 10. Okay, then for the last part, it says access to the pool is by the side AB. It says, given that AB must be at least 1 meter. Well, AB was y. So they're saying y must be greater than or equal to 1. And it says, determine according to the model whether the swimming pool with a minimum perimeter, so the value of x equals 10 gave the minimum perimeter we saw earlier, would actually permit this. So we need to just go to our value for y. Well, we had the equation for y from earlier, so let's copy that over. That was our equation for y. Let's see what this is doing when x equals 10. Well, we get y equals 50 over 10 minus pi times 10 over 8. Putting that in the calculator, 50 on 10 is just 5. And it's minus 10 pi over 8, which gives us 1.073. Which importantly is bigger than 1. So therefore it is suitable. Okay, moving on now to question 13. We've got a trig equation. We need to write it in terms of tan theta. Well, first off, their equation's not factorized, so let's expand the brackets in the first form we've been given. So that would give us 7 sine squared theta minus 4 sine theta cos theta equals 4. And if I want to get tans involved, we're going to have to start dividing by cos, because tan is sine theta over cos theta. Or if I want a tan squared, we'll divide sine squared by cos squared. So dividing everything by cos squared, we'd get 7 tan squared theta here. And then we'd have minus 4 sine theta cos theta over cos squared theta equals 4 over cos squared theta. Now, in the middle term here, this would cancel once on the bottom, and then we're left with a sine theta over cos theta, which is just a tan. So we'd have 7 tan squared theta minus 4 tan theta equals 4 over cos squared theta. Now we could deal with this 4 over cos squared theta really easily with sec if you're a second year, but if you're in first year, you probably don't know what that is. So it's going to be a bit strange how we deal with it. What we can do is we go back to this guy and we can split him up as 3 lots of tan squared theta plus 4 lots to make 7. But I'm going to write the 4 actually as 4 sine squared theta over cos squared theta. Because if I bring over this minus 4 cos squared theta, we could write that all as one fraction, just write it as minus 4 on the top here. And then we'd have minus 4 tan theta equals 0. And why is that nice? Well, that's nice if we factorize that numerator. That'd be 3 tan squared theta plus 4. Or actually, let's take minus 4 out. That's nicer. Let's take minus 4 out. If we take a minus 4 out, then the numerator becomes 1 minus cos squared theta. Sorry, 1 minus sine squared theta, excuse me. Over cos squared theta. Minus 4 tan theta equals 0. And that's nice because we should know, well, cos squared plus sine squared is 1. So 1 minus sine squared theta is just a cos squared. So these guys just cancel. That's a bit of a strange one to deal with in first year. But that is how you do it. We'd have 3 tan squared theta minus 4 tan theta minus 4 equals 0. Part B then says, well, can we actually just then solve this equation? So rather than solve that, we're going to solve the quadratic in tan. So we had 3 tan squared theta minus 4 tan theta minus 4 equals 0. So let's just check that's right. Yeah. So that's a quadratic in tan. If this helps some people, I'll do this. So u is tan, if I set u to tan theta as a substitution, this becomes 3u squared minus 4u minus 4. So more of a quadratic we're used to seeing, perhaps. Then that's factorizable, actually. So let's do that. So if I put a minus 2 in there, that makes minus 6u. I put a plus 2 in there, that takes us back to minus 4u, and we get the minus 4, so that works. So then u is minus 2 over 3, or 2. So then tan theta is minus 2 over 3, or 2. So that gives us solutions of theta is, well, let's use the calculator, inverse tan of minus 2 over 3. So that's minus 33.69. But remember, we can add and subtract 180 degrees to that as many times as we like, because the tan graph repeats 180 every 180. And the other one, coming from the 2, if you go back and get rid of this, so just tan inverse of 2, that's 63.4. 443 degrees, plus or minus 180 again for the same reason. So minus 33.69 is not in our range because we want from 0 to 360. So we can add 180 once to the 33.69. I go up. Yeah, there we go. So let's add 180 to that. That gives us 146.3, and they wanted it to one decimal place, yeah. So 146.3 degrees would be the first one, and we can actually get another one from that if we add 180 one more time. That'd be 326.3 degrees. And then let's do the same thing for this. 63.4 is actually in the range, so let's just copy that one down. And then we need to add 180 to that. That would be 243.4 degrees. And that's actually all we could get. We can't add 180 more to that because we'd go past 360. Okay, then the last thing is, okay, hence find the smallest solution of this equation. Well, the only difference between that equation and the one we had before is we've changed from theta to 4 alpha. So theta equals 4 alpha, or in other words, alpha is theta over 4. So whatever solution I get for theta, where I can just divide it by 4, it would be a solution for alpha. But we'd change the the range of solutions we're looking for, interested in as well. So if I want a solution for alpha that's bigger than 720, that's going to be 4 times that for theta. So the minimum theta value is 720 times 4, which is 2,880 degrees. So we need to think which of these two sets of solutions is going to get closer. So let's just actually, let's just do it. So if we start with the 146.3, and we'll get to the first solution that goes past 2,880. So this one's divided by 10, so that's quite nice. We can just move the decimal point one over. So if I keep going up, we're going to need to get to 2,000. There we go. 2,846.3, and then one more. That would be the smallest one we'd get from that. So alpha could be, just so you guys definitely know, that would be 3,026.3. Oh, sorry, that would be the theta value. You divide that by 4. Divide that by 4 to get the alpha value. That gives us 756.6. So that's the first solution we can get that's closest as possible to 720. Let's go for the other one now. So 63.4 plus 180. But if it's all over 5, we can just sort of times by 2 and then divide by 10. So we're going to need to go a bit farther past than last time. But let's just see where this is at now. So decimal for that, 3,000. Okay, so I've already gone past too far. Okay, let's take 180 away a couple times. So format that back now. Decimal 3,303. We can take off 180 another couple times, I think. Format that. 2,943. And yeah, if I go any more further back from that, it's going to be below 2,880. So we'll convert that one to alpha by dividing by 4. What does that give us? We format. Gives us 735.85. Or 735.9, which is actually the smallest one. So it's that one. That's right. That's this one, and we'll cross this one out. This is the smallest one. Moving on to the last question. It says, prove using algebra that n squared plus 5n is even for all n elements of the natural numbers. So to prove it true for all the natural numbers, let's split the natural numbers up into the evens and the odds. So we can write the evens as multiples of 2. So let's say 2k. We plug that in, we'd have 2k all squared plus 5 lots of 2k. That's 4k squared plus 10k, which is clearly even because I can take out a factor of 2. So that's 2k squared plus 5k. So therefore even. Then if we want to check the odds, that would be 1 more than a multiple of 2k. That's one way of doing it. And plug that in, we'd have 2k plus 1 squared plus 5 lots of 2k plus 1. That would give us 4k squared plus 4k plus 1 plus 10k plus 5, which gives us 4k squared plus 14k plus 6, which again, I can take a factor of 2 from out of. So that would be 3k squared plus 7k plus 3. And again, if this is a multiple of 2, then it must be even. So we'd say hence true for the natural numbers as true for all evens and odds. That's the end of the video, guys. I hope you found it helpful. If you did, please drop it a like, that helps me out a lot, and consider subscribing to the channel to find out when I release new videos. Thanks, and I'll see you in the next one.